All right. So yeah, today we'll continue discussing the Yakasaur, that project. Okay, cool. First of all, I helped run a hackathon this weekend and I went pretty hard, so I might be a little bit out of it, adjusting, and I think I'm losing my voice a little bit, but it was great. It was great to actually like co-organize a hackathon again. It's been many years since that happened, and yeah, a number of cool projects. Nobody built. It was a climate and sustainability hardware project, hardware hackathon, and like robotics was on in scope, but nobody like built a robot in 24 hours, which is kind of a bummer. I actually did build a thing, but I didn't build a robot because that was like I was mostly helping other people. But I built a cellular water well level sensor. It's kind of cool. Uh, but anyway, um, is this the spreadsheet? Yeah, okay, this is the kind of system.
Yep, this is the one I was taking notes on last time. So
This is the bomb of bombs and an initial kind of architectural
yep.
foundation here. So yeah, I mean, the thing that I would love to have happen today is outline some small, yeah, really outline little buckets of execution that have to happen that can be compounding and are that dovetail each other. So that's really the thing that I would push for on this call, is to allow the scope of this to allow everybody to execute on it, because I can certainly lead the MCAD stuff or whatever subsystem, but me doing this for 2 hours a week will probably take several months to produce stuff versus like if we all put in some time on the subsystem. So yeah, I guess what do we need? What's remaining to kind of isolate out small buckets of things?
Last time I think we started defining MVP rover. Is this the breakdown we're starting with? And is this also roughly the factorization into individual buckets that people can sign up for? Or no, this I don't think they're one-to-one, but it's like the data is in some form here. Rhett, you weren't here last time, right?
Yeah. Yeah, I missed out. Not quite sure where we left off.
All right. So last time I think, let's see. Yeah, we talked a little bit about top level missions.
I have a slightly different suggestion.
Mhm.
We already decided that this is going to be the last Yakasaur meeting, and next week is going to be the last modular meeting before we decide which one to do. So how about we go backwards, ask ourselves, what more do we need in order to fill out the Yakasaur? Instead of, asking, where we are and what we'd like to do.
I think that's pretty interesting. Actually, I think what would be most relevant to that is to figure out how they combine, because I do think there's definitely a certain overlap that could be achieved that would allow both of them to continue in interesting ways. Is that true?
That's definitely one of the directions I brought up last time because I saw it in the chats, but yeah. But
So I
today
think I suggested there are three possible directions. We do A, we do B, or we do some creative synthesis of A plus B. And I think that's actually a full hour discussion that we are not ready to have yet. We need the third sessions on both tracks to be complete before we do that. So I think the question now is, what's a useful way to like develop this line of thought fully in this third session? And my inclination is actually to not anticipate the modularity discussions right now and just like work out this in its own logic. And if it ends up being like a monolithic design idea after this today's session, then we can talk 2 sessions from now about, all right, how do we take that monolithic design and bring a modularity aspect to it or something like that. But right now, I think we should finish this design exercise in its own sort of internal logic. Like,
I mean, if that's what everyone would kind of like in this exercise, yeah, we could do this in a relatively traditional way that we would develop this system, which would be like we identify subsystems, mostly like pseudo independently develop subsystems. There's systems integration step, and then full system bring up and integration and testing, and then that's the final solution. This system is so small and relatively simple that's sort of the beauty is I think we could all have the complete system before us, even if we're executing on a subsystem, which really closes the loop on the integration step, which I think is pretty cool. So like in this project, it's kind of interesting at the hackathon. That was really more of a sensing situation. So there were like 3 sets of parts that I purchased and made available for the teams. One was compute, the second was connectivity, and then the third was sensors. This project requires all 3 of those categories plus a 4th category, which is actuation. And in terms of how to break down what this system is in terms of like workloads and given skill sets that we have, they don't have to directly coincide with each other. But I would say, like, I know Rhett had already brought up kind of like a low level hardware. So it's like a Zephyr based or like a RTOS based OS for the lizard brain. Or I don't remember. Was a
I guess we're talking about like the software I scraped together for my Arduino based
yes.
rover early on. Yeah. So it's kind of like a lightweight C framework for kind of integrating different parts together on Arduino.
Was that using an existing RTOS framework, or that was bare metal?
It was all just bare metal.
Oh, cool.
It was really just like taking Arduino and just going a little step further past what the out of the box stuff is.
Yeah. Okay, cool. Yeah, because like what I'm getting at is like what we're ultimately doing is just integrating a lot of off the shelf stuff, and then once we can't do that any harder, then we're building our own stuff. So like for instance, the mechanical design is largely just borrowed and glued together COTS parts, which is like very nice for cost and speed and velocity. On the software side, though, one example would be like if Rhett wants to port his existing Rover OS onto this target, which is where I think we're talking about the Espressif hardware, which is like 32-bit Tensilica. You could port that over, and then that could be the Lizard Brain OS. And then maybe that's something that other people could also contribute to, is like the Lizard Brain environment, especially the Lizard Brain environment that can access cameras. Because I'm trying to think, this is where the modularity piece comes in. Like if the Lizard Brain is controlling the whole system, then the Big Brain compute module can be modularly detached and attached and powered up and down independently, which is not that modularity is a design constraint here.
Can you explain what you mean attached, detached? You mean physically? I lift it up and take it away?
I mean, like the robot can still perform a mission with the large compute offline.
What do you mean offline? Turned off? Or that actually you disconnect it and take it home for repairs?
I think we need not define that. It could be any of the above.
Okay, just wondering what you meant.
Yeah, like it could be in the sense that like literally the wires are cut, or it could be in the sense that like we don't have enough power to turn it on. Both of those things can exist at the same time. And I think that
what's your so just, I guess let's get into implementation details, but what's your experience with, I guess, lizard brain amount of compute and having some connectivity to actually interact? That was the biggest challenge on my really low powered Arduino setup, was like literally interacting with the radio or trying to communicate with it is pretty hard. So like that, uploading a photo somewhere is non-trivial.
yes, that's correct. That's completely correct. And that's kind of why I was asking if you'd use a heavier stack like Zephyr that would potentially already have some drivers and things like video compression available. Because like if you don't have Linux, like look, I would push pretty hard for the system to not have Linux as a requirement. Because the moment we have Linux as a requirement, we're just SOL on power. Like it just immediately makes everything extremely hard. So
Right.
yeah, so like as an example, this is, we're connected to the internet with cellular in small payloads at a time. And then this is the I and compute. And we just, somebody would need to bring up a stack that could actually run on the lightweight hardware and compress and send images. Because there's this question about like, we could emulate the sort of Sojourner rover approach, which is to like literally just send and compress images, and then you tell the rover what to do from a big brain that's like not on the physical location. So it would be some server that like processes the image and then tells the rover a command set. But that all needs
Well,
to happen.
you could always store the images on a shared storage, like an SD card, so that the higher end compute would like compress it take it from the SD card when needed and when there is power available, and compress it. And the lower end compute just stores it on the SD card. That's what it does.
Certainly, but like, I mean, I don't know, like the thing I would just encourage here is definitely like building this and shipping this will answer questions automatically. Like there's so much here that you will never know without it being deployed. About so many, even up into and including these like architectural details and like how the system will work.
The reality of trying to run a Raspberry Pi 4 or even be able to turn it on or off with the limitation of being able to recharge that battery via solar, like having that in my backyard might be incredibly enlightening. Just like, okay, actually I can only run this for 30 seconds. That changes a lot. Suddenly the boot times matter.
Yeah,
but we then have the opposite problem. If I have a Raspberry Pi, it's really easy to add features like, oh, a VPN. Let's add a VPN. Oh, let's add a little bit of image processing. But if I have a bare bones chip, so it's really difficult to add stuff. So I'm not against having a minimalist compute as long as we have a very robust, let's call it cloud or base station support for doing real processing, which does run Linux. In other words, if I can have a base station connected to my mains that's on, wireless communication with my robot, so no problem. The robot is lizard or nematode, and anything interesting I do on the base station. I don't know if we're willing to do that trade-off, but otherwise, you're going to get a robot which is really, really simple. And that means that anything you want to do on it, it's like going back to the 1980s. The early 1980s. 6502 processing.
Yeah, and is that uninteresting? I mean, it took millions of dollars to do what we're going to do for $100 now.
It's difficult. It's not interesting. It was interesting programming the Z80Zen. and it would still be interesting now, but it's very difficult. If I want to add some image processing function, I want to add a connection to ChatGPT. I wanted to take an image and send it to Midjourney. I can't do it. If it's a Raspberry Pi, it's very easy, 3 lines of code and it does it.
How are you connecting to the internet in the middle of Mojave?
That's exactly the point. I'm not trying to build right now in the middle of Mojave. I'm trying to build in the park next to me. And by the way, I just have to answer your question. If I take my cell phone and attach it to the robot, it can connect to the internet in the middle of the Mojave.
Are you going to stand there the whole time? So like what I'm getting at is we need to define a mission here. Otherwise there's no point in any of this.
Yeah, I think that's.
So like there's no point in talking about this at all if we're going to like stand there with a cell phone. So like what's the mission?
I think if the idea is to drop off a cheap rover that we're going to either lose or probably not, maybe or may not recover, may get stolen, and we want it to be able to run for multiple days at the very at a minimum, that changes a lot. That sets a lot of restrictions.
But if I can turn on cellular modem on demand, so yeah, I can only have it on for 30 seconds, but that's a completely different world.
And we think we have connectivity. If we have these cell phone modules that we can attach, we can get some amount of connectivity to this thing.
That
Probably
is what
easier
my
than Mars.
assumption was, that at least we'll have some cellular connectivity.
I'm trying to follow this discussion and make sure it captures some version of it. Is this the decision we're talking about? Whether it's a lizard plus big brain on the rover itself, or a lizard plus a base station, or a lizard plus a big brain plus a base station, and one of the bigger computes has a cellular modem. Is that roughly the design space we're talking about?
Not quite. The little compute has a modem, not the big compute. In other words, if you look at the scale, it could be lizard brain plus big brain, just big brain, lizard brain plus connection to a big brain, and big brain plus connection to a huge brain. Okay, so it's like a scale where the most challenging one is having the lizard brain. And my problem is not that it's challenging for me to build, that's fun, but if we want it to be something that other people use, it's too challenging to play with. It's not at the level of ease of access that people are used to today. But Joshua's right, if you put inside a big brain, so what's the mission? Is it Mayor's living room, or is it the Mojave Desert? So we need to decide that. I'm agreeing.
I think Mojave Desert, because I think autonomous communications is one of the bottleneck capabilities that's worth learning about now, as opposed to standing next to it with a, I don't know, mobile Wi-Fi hotspot or some other like jury rig thing. This is the next bottleneck that levels up from like domestic rover experiments to field rover experiments. So yeah, I think we should go there. Some sort of modem.
Yeah, but domestic rover experiments sort of have little to no constraints. I think that's sort of like one of the challenges. We're like, oh, we can actually have infinite amount of compute and infinite amount of connectivity that almost gives us too many possibilities. Whereas if you choose Mojave, has to run for a couple days, like, wow, you're suddenly really focused on exactly what needs to be built. And so understanding the connection between the mission and the requirements, I think, is what we're exploring here.
And we're using Mojave as almost a placeholder pointer, but so long as it's out in the field and doesn't rely on your home Wi-Fi network or you standing around, that's enough for me. Like I'm willing to have it like, in Griffith Park, half a mile away, and I'm at home.
So like once you're not on Wi-Fi, your options get really limited really fast.
Yeah, I like that constraint.
Why do you say that? Is there any place on Earth that doesn't have a space link except maybe Antarctica?
Do you want to pay 300 a month for each
I-
rover?
Now is a question, I'm not disagreeing with you, but now is a question, if we emulate SpaceLink using a cell phone module, which doesn't cost $300 a month, is that acceptable? Also,
It depends
Mars,
on
I
the
expect to
it
have
depends on the
space.
cell phone module. Like I think maybe perhaps one thing that you're missing, this context which I have, is there's a lot of different levels of connect. Even so, cellular specifically, I cannot emphasize this enough. It's extremely complicated, and
Yeah.
there's no, like, seriously, there's a number of different types of modem and different bands and different bandwidths, and then there's different carriers. They all argue about how you connect, and then there's different plans and meterings of how you utilize that network. So, like, if you want to have unlimited data, that's sort of like one class of modem
No,
category.
no.
If you want to have a finite amount of data, then there are other options that emerge. However, yeah, the Nordic, the thingy 91, it's an okay modem. It's like
Yeah, no,
I think it's a cat
so
one.
Josh, I have a suggestion. My suggestion is that we pretend that we're using SpaceLink, but that we emulate whatever SpaceLink gives us, I don't care what it is, on Mars, yeah? We emulate it using cell phone. That's my suggestion, which means we won't be able to go into Mojave Desert because maybe not next to a highway, we don't have a bandwidth which corresponds to SpaceLink on Mars. But we can go, 400 yards from the highway. That we can do. That's my suggestion.
Yeah, one thing I would push back on here is like this notion that Mars will be so different from Earth when we actually colonize it. Like, we're probably going to be using the same part number cell modems on the towers on the planet. Like, like literally, like, just think about how it would actually go down. Like, it probably wouldn't be that different. There'd be like an interstate highway with like a tower. like, I don't know that, like, it's not like it's broken. Like, it's a model that works.
And I'm not sure I understand what you're arguing for at all, Mayor. When you say emulate Starlink, do you mean the rover sees something like a Wi-Fi hotspot? So as far as the connectivity is concerned, domestic versus desert is not that different because it's both a Wi-Fi hotspot?
No. What I'm saying is, we have this question of how much processing is on it. What I'm saying is the question is easier to deal with if we're willing to accept that the lizard brain is capable of connecting to, let's call it a standard computer via a wireless link. Now, this wireless link will have data limitations like Starlink and power limitations like what we have. The rover can't be live connected like a Wi-Fi hotspot, okay? It only has a little bit of power. We understand that. Okay, it can only use it when it can use it. But what I'm saying is that we emulate it. What's the word? We choke it so that the cost of communication and the amount of communication it can do is like what we would expect in this future Mars. That's what I'm saying. And therefore we work back to making a rover which has a lizard brain, but it's still something you can play around with because you can add features. Let's call it your base station. You can add features to your base station, but you have to be clever so that your rover will be able to take advantage of them. But it's not that you can't add. It's not that any feature you want to add, you have to reprogram it. No, you can just put it on, but now you have to fiddle with it so it can work under the constraints of you only have enough power for 30 seconds a day.
Again, I'm like, you've lost me a little bit. So now when you're saying lizard brain, are you saying it's a more powerful SPC like an ARPi that's artificially and virtually choked to act like a much simpler board, and then you can kind of like design the lizard brain on the ARPi, or is the rover actually
no. If I understood the design Joshua is suggesting, we have Arduino, basically. That's a CPU that we have running on that's a lizard brain.
And
And if
there's a
you
low
want to
power
do
modem to connect to the base station, and then that
exactly,
something. Okay.
exactly. But that modem will be limited according to what we expect in the Mojave Desert.
So ultimately, like my kind of objective here is to ship a robot. And it's like there's a point where you just kind of gotta like if the mission is to not actually have something that's field deployable, that's sure, that's fine.
Oh.
I personally think it's far more interesting to actually like put something out there and have it. There will be amazing stories about like it getting stolen or like somebody like or some wild animal, it'll get stuck. Like there will be really interesting things that happen from deploying this, and it will also, I think, frame so many problems in a very interesting way. And I actually would push back on the notion that it is a placeholder. The notion of a desert is so different from another planet or moon. I think there's a lot of likeness in kind of like what the robot will look like and how it would be designed. So like this is not an uninteresting exercise. Like it's not off topic. Is I guess what I'm trying to understand, Mayor. If you feel this is off topic in some way.
No, I just want to make sure it will be fun for people to play with the robot, not just us. That's my only concern.
So what about, so if I understand correctly, the two proposals on the table are there is Arduino brained robot that talks to a base station that emulates the Mojave environment versus an Arduino brained rover that directly uses a cell connectivity breakout board to actually operate in the Mojave Desert. And for some reason, you think the former suggestion is easier and more accessible to more people. Am I understanding that correctly? So what makes that easier? Both sound equally hard to me. That's why I'm very confused about what you're actually proposing and how it differs from Yasha's proposal at all. Like I don't get the difference at all, other than one has a base station, the other doesn't. So is that the difference?
No, the difference is what happens when I, as a hobbyist, want to add a feature that I saw on the internet in somebody else's different design of a robot. Taking somebody else's design of a feature and pushing it into my lizard brain is really, really difficult. Having it run on the base station and just having my lizard brain send data to the base station and get back results under limits of power, time, and bandwidth is something that as a hobbyist I can do much more easily, and then I can, copy features that I saw.
There's a few things I would say to address that. The first is that's a problem we don't have yet. So like once we have robots that like people are interested, like genuinely, like once there's a GitHub repo with a robot and like a Wired article that people are like, oh, what's that? Then that's an interesting problem. So it's a problem we don't have yet. Hopefully it's a problem we will have. I really genuinely hope that'll be a problem that comes up soon. So the second piece is, if you've heard of the Arduino framework, it's just that, it's a framework. It's not actually hardware. The Arduino framework was born out of this problem of embedded microcontrollers being intimidating and hard to set up. Because before there was this unified framework, it was very specific and took a lot of time that was not copy and pastable across multiple targets. And that's where the framework came from. So maybe this is an excellent problem for us to have, to identify our own sort of framework that makes it this hardware accessible. And that could in itself be a very interesting thing. Because like,
Yeah,
ultimately,
accessibility is something like we could solve for later on, right, Mayor? Or not?
I'm not understanding something here, but maybe I missed out 2 months ago. I thought our goal was to either make a simple robot or make a modular robot, but in either case, something that people outside the YAK collective could have an easy time copying it. I know the Arduino framework was built because microprocessors are intimidating, but it doesn't solve the problem that if I see a feature in somebody's image processing library, there is no way I can fit it onto the Arduino if that's all I have. But if by definition my rover is able to talk to a base station and it has some sort of budget, then I can start trying to fit that feature in. Okay, using tools.
So Mayor, I would push really hard to say that, like, I think the ways that the sort of API or interactivity can emerge will be very interesting and may or may not actually be on the robot hardware. And that could in itself be interesting, where it's actually a fleet command kind of a thing, or like you run a replit, which is like the easiest way to like program something today. Like you open a replit that actually uses like the Yak script, and then like the Yak script interacts with the fleet and like controls the fleet in a very digestible, high level way. Yak script could even be like a Python library, if you will, that controls a fleet of an entire fleet of robots, and you don't even think about the hardware. It just controls, like, if you see a rock over there, if 3 of them see a rock over there, they all go towards the rock. You know, like, but these are all things we don't have yet, right? This is like, once you're in the field, it's like, oh, okay, what now?
Just to add to that data point, I'm probably the least experienced at this level of programming compared to you guys, and I actually found it easier to make the Arduino do things than my BlackBerry BeagleBone Blue or the RPi. So I say actually, even though you can't do complex things like camera image processing, basic things like motor control or an ultrasonic sensor or whatever, I found the Arduino actually a much easier learning environment, and I've gotten farther along with it. That's one thing. And the second thing is I don't see an either or decision point that we have right now. Like we build the Arduino lizard brain rover design now, and it seems like if it has the right kind of modem, it can, if we add the base station design later, it can always talk to that. And the other thought I had was, if you do want the more complex high-level programmability, that seems a role not for a base station, but an even lower level of accessibility, which is simulation. Like build the Arduino brain robot, build a version that runs in one of these, Copilia Sim or one of the others that we pick. And then people who want like really expressive, rich experimentation, play with the robot model in the supported simulator. So the base station, I think, can be added at any time. But in the meantime, the barbell strategy of lizard brain, simple rover with a radio modem plus simulator seems like the 2 endpoints to work on.
When, the fact that you gave a radio modem is a very part of the problem.
Why? If we specify the part and the assembly of the rover is install the Arduino this way and then attach this cellular modem this way,
but it changes the power issues and other things like that. And Josh has said correctly, well, which radio modem are you going to put in?
I mean, those are things we design. They're not meant for new users. Like once we design and test out the design, those problems are solved. It's like this Arduino with this modem works with this power consumption, build it according to these instructions. That's done.
Of course. I'm saying Josh's point about let's define our mission. That's what I'm talking about. If our mission is Mojave Desert, you're not going to put in a Wi-Fi modem. Okay, it's as simple as that.
Wait, is that true, Yasha? Like, what's the communication constraint of, say, the Mojave scenario? Like, how much communication can we handle? Can we handle the Nordic semi cellular board? What's the power or whatever it is? Is there a
It's made for global shipment trackings, that SIP.
Well, it's just, okay. Again, I think very complicated. That is a hard question to just answer. Depends if you're using a narrowband modem, wideband modem, how many bands you're using. Like there's like a lot of stuff. Generally, I do think like if you have cell phone reception is a pretty good litmus test of whether this Quectel modem that we may be using is going to be able to pick up a signal in that environment. So like if you have cell reception, the robot is going to be connected, and that's kind of it.
So, and this seems like within scope for the design, right? Like it would add a certain amount to the cost of the rover. And once it's added, it can either operate silently in the desert when there's no cellular. And if there is cellular, it can do a certain amount of communication based on the power budget. So seems like we have our design target and mission. Like Mojave Desert scenario with communication capability, power limited communication capability, is that a feasible mission design?
Absolutely.
Okay, so what are we arguing about? I just don't get what.
I just want it to be feasible, but I believe in a sense it allows you to add functionality via a base station. I'm calling it a base station. You can call it a cloud. It doesn't really matter.
And I don't think we've precluded that option. I think we can add the base station design once we get this.
Oh,
robot
it just has to do with defining your mission. If we agree that the mission is a world where you have a space link, but we're only going to do it where you have cell phone reception, not going to use space link, everything's fine. I'm okay. Okay. All I'm saying is that if we build a robot that only has Arduino, we make it really difficult for our users to play around with it. That's all.
There's been no requirement in any of these meetings or conversations saying that it cannot have a Linux running. Like,
no, you just said half an hour ago that if we have Linux running, it kills the battery.
that's factually correct. Yes.
And I'm agreeing. Okay.
So
I'm not disagreeing. I'm agreeing, and I'm saying, but on the other hand, the reason why I want Linux is because otherwise it's really difficult to play around with. Not as a Arduino hobbyist, as somebody who saw a feature somewhere else and wants to copy it.
I'm just going to disagree with that. Like, that is your opinion. And there's even been people on this call that wouldn't directly agree with that. And we also don't have other users who are literally telling us that in this call.
This isn't a call where each one of us represents a user. I'm representing theoretical million users. But if anybody here thinks that it's easy to add an image processing function to Arduino, please tell me how.
There's a number of libraries available to do embedded image processing.
But I found a library. Somebody wrote something in OpenCV2, 100-line script. That's what I want to use. I don't want to rewrite it. I just want my robot to be able to use it. Sometimes.
I mean, the other thing I would argue, frankly, is we're also entering an era where doing highly specific programming gets a lot cheaper and easier with these LLMs. So I think that wall will also break down, where like if you want to actually, what it would take before for us to write an embedded image processing library is a lot easier now. And I don't know, like Anuraj, I think you've probably done more like bare metal image processing and DSP stuff, but like,
yeah,
like,
so it's easier for somebody who does embedded, I would say, at least now. But it's still like for a beginner, I think it would still take some time. So for an app, from an applications point of view, like I think it would be easier for somebody to use a Raspberry on like from the user space part, I would say.
yeah.
So how hard would it be to specify a configuration that's lizard brain, but have like basically a plugin capability to accept an RPi, and that just puts it in a different state where it's like drawing plus 4 watts and your battery will run out that much faster. So it's just a headless lizard brain robot that can accept neocortex RPi. So it seems.
I had thought that was the design this entire time. That's why I'm pretty confused. Like that was my understanding of this architecture.
I think this would also.
Yeah, but you have to define what wireless link we're willing to have. I'm not disagreeing with what the design was, but what wireless link are we willing to have? That was the question. How much wireless link?
And if you have a base station, the wireless link would simplify how it would be a standard Wi-Fi.
No. I'm just using base station as code for something connected by wireless link. I was saying that I want a wireless link to be space link, not because I'm planning on building space link, but because it's reasonable to assume that in a real mission, we'll have space link connectivity and that we would emulate it using a cellular modem, and we'd only use a rover where you actually have cellular connection. And if anybody wants to buy $300 a month space link connection, they can do that too. That was
Nothing about this current design that precludes somebody adding a Starlink base station to the design. I mean, that's very much what they could do. However, base station with the current connectivity technologies we've added to the system will only have 500 feet line of sight on Wi-Fi, which is pretty uninteresting in my opinion.
So we are at the 45-minute mark, and we spent about 15-20 minutes on what is still an extremely confusing discussion to me, because I don't see the argument point here. But let's say that, yeah, the question is, what kind of connectivity do we put at what locus is one of the design variables here. It's either going to be one of these Nordic semi-type boards or some sort of like Wi-Fi link that emulates a Starlink link connecting to a base station. How about we defer this later in the design? So what have we locked down in the design so far? Like, is how far towards completing the definition of the Yakasaur is this tab? Like, what's left to decide then? Because we need this, I think, somewhat fleshed out before we can start filling out like what bits and pieces different people take on. And I think the mission, despite all this radio modem disagreement, is I think we want a rover that can autonomously operate far from humans or Wi-Fi access, right? It seems like we all agree with that, though we are disagreeing on the specifics.
I guess
Everybody
so.
agree with these two statements? This and this mission and yeah, this highlighted part. You agree with these two statements?
Yeah.
Okay.
Yep.
So I think we've decided the mission then. This to me is all I need to know the mission. And then beyond that, then there is like the specs where I think Yasha has like nailed down several pieces, like the material, the motors, the compute you guys are still arguing about, and the communications you guys are still arguing about. But the basic MCAT design seems done. So once this tab is filled out, I think then we can start breaking it down into who does what. Did I miss anything in this state of the discussion?
No.
Yeah, I think as far as I understand what people here want to do, yeah, is good. It just needs to be, yeah, just need to figure out how we can collectively execute.
Okay. So let's stare at this tab for a bit and maybe pick out things that still need discussion. So for example, if we are doing minimum capabilities on an Arduino class board, what does autonomy look like? Is it a bunch of like Arduino scripts that do very basic random walk type navigation in the desert? So not Python scripts running on an RPi, the basic script would be an Arduino script doing like lizard.
Yeah, similar to the architecture that I had on my Arduino based one, is that you've got, if you think about it as a single program that you have running on your Arduino that's in a run loop, and it can pick up new commands or new instructions from cellular or whatever it's, in my case it was like a radio packet modem, and then initiate actuators, initiate taking the camera, take the bytes from that camera and send it back over the cell connection. And that's the only sophisticated part is just trying to juggle these multiple things at the same time. So you can't really think about it as like a Python script that's going to do this one function, like move the left motor. It's more like you've got this program that's in C that's going to try to juggle all these operations potentially.
So yeah,
at least that's my.
So no ROS, right? So this is not ROS level message passing abstraction. This is just a single main loop running both motors and maybe polling the.
Well, the communication protocol that you might be using between the compute and whoever you're talking to could potentially be what ROS uses or operate as a ROS node, or not.
Yeah, we are all using some sort of ESP, right? Or at least some.
I don't know that we need to completely nail down that part.
Yeah.
So like, I could suggest for this project a solution. Like, I do this all day, so I could do that. Would be great is if people have opinions and make it better. So like one thing that I would push pretty hard on is selecting a low level RTOS to run on this. I would not suggest bare metal. And I think this will actually ease some of the concerns about the pain of doing things on lower level compute versus higher level compute. So, there are things like the Zephyr project I've mentioned is kind of specifically designed to be agnostic to the level of compute. It can run on really low stuff or it can run on pretty heavy stuff. If like that's something I would suggest if nobody's looked into Zephyr, we look at Zephyr. Otherwise, maybe somebody has an opinion about how to incorporate FreeRTOS into being kind of like the rover base, kind of like brain OS. I mean, we could even run FreeRTOS bare metal on the RPi. There's no reason why not. We could run Zephyr on the RPi instead of Raspbian. We wouldn't get as many libraries, but like these are all, people do things a certain way, but there's no reason we have to do it that way. So this is something we could look at as well.
This tab, the reason I called it MVP rover is I think the place to start is specify the minimum configuration. So if the minimum is going to be the lowest powered ESP board that we support, that will be sort of, so if your RTOS choice runs on that, that's what will drive the choice, I guess. So that's why I was bringing this up. I agree, we don't need to nail this down now.
ESP has better support for FreeRTOS, and like Zephyr is like just getting started on ESPs.
Yeah, and we don't have to use the ESP.
Yeah.
We could use other STM like a Nucleo or something that has more horsepower. Like there's no hard requirement there. I know Zephyr does run on Tensilica.
Yeah,
and they
the
also have
support is a little less. I think they started just 2 years ago, but like FreeRTOS, they have been running it for several years since they began. So,
but that's
just a
like a
lag.
good example of maybe something that you could look into and be like, yep, this is a good thing or not a good thing. Because I certainly haven't looked into it in a little bit. Yeah, we anyway, I can't say, but yeah, I haven't looked at it recently.
All right, Anuraj has a task in this tab here. Pick the RTOS plus board combo for the minimum viable configuration, I guess. That's the task here.
I'm happy to just own the MCAD, but Venkat, I'd love to collab on that if you want to do on-shape stuff.
Yeah, you understand the advanced functionality a lot more. So basically, yeah, I'm happy to contribute to the base design and then do what I can. So,
there's actually quite a bit of detail and new. There's probably 3. I honestly think there's like probably about 20 hours of work for it to be like legit production ready design. So that can certainly be kind of split up and multiple people can tinker on that and remix and mix it up. There
think
is
it's 20 hours divided into 5, kind of.
There's
I don't
always
think
penalty.
MCAD will fragment that much efficiently. So I think at most 1 or 2 people should work on the CAD. Beyond that, the coordination overhead is probably higher than worth.
Is there anybody here who's like EE board layout other than me in terms of like doing board stuff?
I used to do it long ago, but yeah, I've moved up the stack. So I did it until like 2017 or something, but after that I've not done it. But I did that for like several years.
Do you miss it?
It's like tedious. It's a tedious work. So I didn't enjoy it that much. So I just moved up the stack. But I can
What do you
do,
mean by board layout? Is it like a larger board that holds the
yes, PCB design. Are you talking about that?
Yeah, like a custom
Yeah.
PCB. If that
Yeah, if needed, I could do it, but like I don't enjoy that kind of work.
do we need it? Like, why do we need a custom PCB?
Yes.
Can't we just have the
I
board?
was going to ask, how do you know? How do you
it
know when you
is,
need to?
that is not, I'm not pushing for that. There just does, so there's always comes this point where initially prototyping something, there'll be like a capability or execution sort of like gap on a team, and that team will compensate with their strength to overcome that gap. So like, I'm just asking this because let's say it does turn out that it would be highly efficient and productive to lay out a small carrier board of low complexity, right? Like very simple stuff, just to kind of make it easy to literally get stuff out of an Amazon box and assemble it without using loose wires. That could actually be worthwhile very quickly. And I was just curious if that was something that other people had any experience with as well.
Yeah, so
Otherwise, we would be filling that gap with like raw small hands and soldering.
Yeah, I was going to
Yeah.
say, I have a
So
lot of experience with really tiny wires and soldering them.
yeah, at some point, all these connecting all these kits will become like annoying, and like it might be better to have like a simple board that you could just plug the ready-made off-the-shelf components. So
And just so I get an idea of what you're talking about here, the things that would go on this PCB are like what? Some motor controller parts, some sensor stuff. Like what else goes on there? What are the things that would go on this board?
well, I mean, we need to fully.
Let me show you exactly what I think he's talking about. This board in the back has a bunch of shit plugged into it, and it's a bunch of wires and a soldering mess. And if there's a problem, it's one of those connections. You're like, which one doesn't have solder all the way through?
And it especially helps for the field robustness. Like the breadboard stuff doesn't ship well and doesn't bump around well in the field. But okay, so if we do need a custom board, it sounds like that might fall on me, or the project could recruit somebody who is curious to maybe operate some KiCad
Can I
or something.
ask why
I'm
is
curious to
it-
learn if you can point to some good, easy learning resources. If it's like a simple workflow similar to Onshape that's within my learning reach, I'd like to try and learn that, but I know nothing about it. I've only done soldering and breadboard stuff.
I would highly recommend knowing at least how it works to manufacture a PCB once, because it's very yeah, it like is a whole new view of the world once you're like, oh, it's literally just like copper carefully laminated together. That's all it is.
why do we need an electronics layout? Can't we make do with 2 or 3 standard components and then just have a connector?
Again, I don't know.
No,
This
I'm
is
asking.
purely-
so like you could survive with the quick connectors for many of the connections, but I think like
No, that word you used, many. That was my question. Do we have many connections, or do we have only a small number? I don't have any feeling for it.
I
Red,
think
what's the complexity on the one you just showed? Like how many wires and things are there?
Yeah, I think it's probably going to be about exactly that same amount of complexity, which was already starting to get a little iffy, just because like there was a radio component and that's got like 8 wires that have to be connected to something else, and then you've got a motor controller in there somewhere, and that's going to have like, I don't know, 6 that have to connect to something else, and so you start just getting into a little bit of a, just that many wires is already starting to get a little tricky.
Oh, and I can add a data point to that. The BeagleBone Blue, the reason I picked it is because it actually finesses and avoids this problem. Since it integrates the Black's robotics cape, it's actually kind of done this job, and it handles, so my thing has 4 drive motors, 4 stepper motors, and if I had done that with like just the BeagleBone Black plus breakout boards, that would be a huge mess. So yeah, that's another data point. So I think I'm also already past the point of complexity where a single PCB would work, and the BeagleBone Blue is in fact that kind of like integrated thing.
Yeah, but this robot is a lot simpler. It only has 2 motors. And I'm wondering if there exists Arduino type board which has what we need on it. I'm just trying to understand, maybe we can bypass this problem, at least for the basic model.
But that's what I'm getting at, is what you're saying is you're saying, oh, because nobody here does the circuit. Like if somebody here lays out circuit boards professionally, they'd be like, I don't want to deal with hardware. I want to lay out a circuit board. Like, what do you mean? I don't want to. How
No,
would I ever solder? I don't own a soldering iron. It just shows up, and that's like what you do when you do this all day long. So that's what I'm saying is like we shouldn't be afraid to, if that's the more efficient thing, go that route.
So I'm willing to do this just for the
anything we
learning.
don't have to do.
I think this is actually worth doing because I also have experienced the troubles of like, wires coming loose and stuff. But also I think this is a worthwhile learning level up for this group. And one of the things we can try to do is advertise for people. So like we can tweet or cast out, like any board designers want to join the YakRover project. We can try and look for people, but if not, yeah, I'm signing up to learn at least some basics.
I know
also-
someone who did this just for like a hobby, like home air quality sensor thing, and was like, he was doing it on Twitter openly, and it did seem like, oh, with the ability, like the on-demand ability to print these boards is actually not that hard or that expensive to get done. So
All
it's,
right, I
it's
do
kind of
have a hard
inspiring. I was like,
stop.
maybe I should learn how to do it.
I gotta hop.
All right. So we are at the hour. So yeah, we'll continue this discussion later. All
All
right.
right, thanks.